Yeah, so today is just we're going to spend some time on like a bit of a review as well as an extension of some of the concepts that we have covered um, from databases, but also we will have like a lot of time left over, so we can also just take up any questions either from the project or any of the assignments, especially the most recent assignment that was assigned last week on Friday, so can also help with that. But yeah, so what I'm going to do is, so we started with talking about databases. So actually, there is a core concept when it comes to databases. And well, actually, maybe the first question we should try to answer is, why even bother with using databases? And so I think a lot of the examples given so far are really good. So we use it to store our data. Um, it's quite efficient. We can very easily retrieve data. But another thing actually we can talk about is that there's also this element of data persistence. And not only that, but persistence that the data is in one place. And so many users can run the application from their own computers, and they will actually be able to get the same data reliably. And so that's actually an important point. So, we have seen the standard React application. Maybe this is oh, I guess I can't draw on that, but let's just say in blue, we have our React app, like running on the browser. And we have the code, the React code here. So maybe that's also blue. And so far, maybe this is our server. And so the app sort of runs off of our code here. But the most important thing here is that our code is actually getting stuff from the server. Now, this is the part where databases come in. We have a database here. Usually it's like a cylinder. And the idea is that our server is actually going to get the information from the database whenever, let's say, the user does an action. So this is the user. The user interacts with the app. They do something, right? So in the code, that's reflected. Maybe there's some sort of event, user on click event, or something happens. And we then send a request to the server to an endpoint. And we'll see this in more detail throughout the week. Now, the request is caught at an endpoint, and in that endpoint, we will actually then query the database to, let's say, get something. And the reason why, again, databases come in is so that we can have some sort of persistent data storage across many users. So maybe there's like a bunch more users. There's another user, they're also using this, and then there's another one here also using the React app. Now, the thing is, the app would be running, let's say in this example, on some like live link. So they're all accessing the app that's running at some sort of address. Like this app is running at some address, let's say. Like when we use render, for instance, render had its own like special address to run everything on. So it would run our front end on there, and it would also run the back end. So maybe this would all, and actually, just to make it clear, all of this, and I'm just gonna draw a little box around it. All of this would basically be, if we were to deploy this, would be running on some render server. And then this, the database, when we talk about it, depending on the type of database we use, so if we use SQL, I think we're also running it actually on render. But when we go to NoSQL or MongoDB, essentially we were running it on MongoDB. I think it's MongoDB Atlas. So these are just separate sort of servers. Now, in the case of SQL, it's the same server, or very similar. I do think Render has like a attached service that can run Postgres or SQL database. Yeah, Samina?
What do you mean by render? Like, of my understanding of what render is, like it refreshes.
Oh, okay. This is not that. Yes, that is also render, but I mean like this render, uh, this one where we can deploy um, things on us on the cloud, so that many people get access to it. So maybe I guess this was like very briefly talked about. Render, it's kind of like GitHub Pages, which you guys have used to deploy links. Like you've deployed an app on GitHub Pages and it gives you a link. Render is very similar. Render, it's also a service that lets us do that. Okay, and we'll be talking about render later as well. We'll be going through an examples of like how to do that. So there's that. And no, it's a great question. Like, why bother using it? So in this case, now we're seeing a case where it would be good to use it. Okay, so that's good. Why do we bother with using it? We have covered that. Right. So another thing to actually talk about would be, what about like SQL versus NoSQL? So again, some of the examples given, we've already sort of seen why bother with using SQL versus NoSQL. So, one thing that's actually quite important is that so SQL is built on this idea of tables. So let me actually, I'll have one half of the screen where I can talk more about SQL and then the examples, and then I'll have another half. Another half for NoSQL. And we'll see, we can compare like what the same data will look like. So SQL is usually built on this concept of tables and their relationship between each other. And NoSQL is built on documents. Okay. Now, this ends up being very structured. So it ends up being very structured, and therein lies the benefit of using SQL, in that the data you have to force a sort of structure on the data. It can only be of a certain type, and the relationships are also predefined. And so we're going to see some examples. Whereas the NoSQL is unstructured, but usually actually it's often semi-structured, but there's quite a bit of flexibility. So what do I mean by this? Let's say, okay, so let's say I have a table and I'm going to have ID, name, and age. So this is going to be a student's table, and we've seen this example already in the slides, but let's just talk a little bit more about this. So let's say I have ID 1 and 2. Name, I'm just going to go really short names. Let's say, just so it's easy to write it in. So let's say Joe and Amy are our two students. And let's say these are like pretty young students, 19, 21. These are university students. So this is going to be a students table. And so here's the thing. When I define this table in this way, the data that I put in this table can only have these attributes: ID, name, and age. Now, often ID SQL, when you add something, the ID will actually be generated for us. Now, here's actually something interesting. I can have students and I can have grades. And let's say there's like, well, let's say Joe doesn't submit any of his work. So all of these are actually going to be Amy's grades. Now, how can we actually show that? So each grade will have an ID, but then I'll also have a student ID field. to keep track of that. And then let's say a letter grade. So grade is ID 1, 2, well, 3. Now I know these numbers are like, the numbers will be better in the actual database. So this ID here refers to the ID of the grade. Let's say this is A, B. Now this student ID refers to the ID in the students table. So let's say these are all Amy, so this would all be 2, 2, 2. So this is an idea where we can have references across tables. Okay, so what's happening here is that my grades table is referring to entries in my students table. And this is one benefit of SQL. Now, NoSQL can also do this, and we'll look at the analogous case as well. But that's a benefit that SQL can do this. And so the correct term for this, if I'm not mistaken, I believe this is what we call a foreign key, because it refers to the primary key of another table. And this is a primary key, PK. And then this is also a primary key. So again, now you can see that this foreign key, it's a foreign key because it refers to the primary key of the students table. Okay, so I do believe foreign keys and primary keys were covered. So this is just another example of, we're just taking that same like students example on slide 15 of lecture 117, and just we're adding another table, a grades table. We're showing how we can make these relate to one another. Does anyone have any questions about this? Okay, so here I put documents because SQL databases are built on tables, and these are like, this is table 1, this is table 2. NoSQL databases are built on I guess you could call them our collections of documents. So they're not tables, but they're documents. So, and we can actually we'll actually very shortly go into, I'll take this example and I'll actually convert it to what the NoSQL version will look like. Anyone have any more questions? Okay, good. So I see a good question here. How is the foreign key in grades linking to the student table, right? So that link is built in. So we'll learn more about this tomorrow, but when we write the code to create, like SQL is also a language, and when we write the code to create the table, that's where we define that this is linked to this specific table. Like this table, the values in this column, or like this student ID is linked to this ID. So the actual process of linking that actually happens when we create these tables. And that's something we'll look at tomorrow morning. We'll go into the actual SQL of that. And I'm actually going to write that down just so I remember. So SQL creating tables with foreign keys. Good question. We can connect two tables with two foreign keys. Exactly. Yeah, like we could probably have even more tables. Like maybe let me do one more here. So I'm gonna run out of space. It's okay. So maybe like I just do another little table here. Uh, let's say ID, grade ID, and then like reason. So this is going to be an odd table, but this table maybe just has like the reason why someone got that grade or something like that. So let's say this is 1 and 2, and then here we have reason ID, RID, and then sure, let's just say in this case, uh, 2 and 3. So 2 and 3. Um, yeah, we'll just some string for the reason. So now you can see that this bit connects to here. And actually, 2 and 3, it's referring to like these two grades and the reason why that particular we gave that grade. So in this case, now here we have this table actually has two foreign keys. So now it's connected to two tables. Yeah. Things can get pretty complicated, but this is actually the benefit of SQL. The data is very structured, and there's almost like there's sort of that structure is enforced on the data. So that's another thing. And maybe actually let me remove this. I'm going to do the NoSQL on another page. One more thing. So you might also be thinking, why use this? This seems kind of complicated. So I'll actually give another example. Right. So how would the grades, so I need another question here. How will the grades table be filled with the same student ID for multiple courses? Right. So the thing is, the ID, so you're right, the primary key has to be unique in each table, but each grade will have a different primary like key, a different ID. And actually, as far as I know, it's been a while since I've worked with this, composed of multiple attributes. So, right, so you can actually, so the thing is, like, I'll just do it in green. Like this ID is unique to every grade. It's not to the student. So the grade itself is going to be unique because a student will not have like the same student will have multiple assignments and each assignment will have a unique grade. Now, one other thing I guess I could talk about is that the primary key, it doesn't just have to be the ID. It can be multiple like attributes. It can be the grade and the ID. But again, like as far as how we fill these, how we create these, like that is actually, we would need to write a query that can create it. Yeah, it should be unique. Yes. The primary key should be unique for each entry in that table. So in this example here, notice how like this is all the same student ID, but what's unique across each of these is the ID is this ID, the grade ID. It's 1, 2, 3. Even if the student ID is the same, these are still unique entries because no. So the table. So how does the table have multiple primary keys? So the table does not have multiple primary keys. There's only one. It's just that you can have multiple foreign keys. So notice that this table, this grades table, has a student ID that connects it to the students table, and it also has this reason ID, which connects it to this table here. When I mentioned the primary key, so well, we can talk more. I guess that's more for tomorrow, but yeah. Now, when it comes to primary key though, it doesn't just have to be one attribute. Right now, we're making it just be the ID. It can be multiple. The primary key can be made up of many of these columns or of these attributes. It could be the ID and the student ID, and in that way we can have like more uniqueness, I guess. But in this example, it's okay. We can just have one. All right. So there was one more thing I actually wanted to talk about. Exactly. So the ID and student ID, we could make the primary key be both of those together. And then you can actually have more options in terms of like you can have more unique values if you gather them together. Yeah. Because then the same ID can have two different student IDs, and then that's two primary keys instead of just one primary key or any number of student IDs. Okay, so there's one more thing I wanted to talk about, and that was the idea of a transaction. And let me try to find which slide mentioned this. Right, so slide 6. So that's another reason why we use databases. And I actually wanted to mention that because it's actually quite important. Um, so these transactions, we define them as a set of one or more operations used to guarantee that a database remains in a consistent state, even in the face of failures or interruptions. So, SQL actually has a really good way of handling these. And let's actually just talk about like transaction in general. Like imagine you're like, this is your like bank account. And let's say you have, I won't go too into detail, but I'll just to impress upon the point that, you know, at any one point in time, multiple things will be happening. Like you might deposit, let's say you deposit $10, and then let's say you get an electricity bill, which is minus $110. And then you get like your boss, let's say, deposits your paycheck, which is plus, $200. These are all transactions that are happening on uh, on, let's say, your bank account, like, which is an accounts table or something like that. And so that's another thing that's important. The database has to sort of decide, it has to handle like which of these happens first, right? Because if this happens first, you go into overdraft because now you're in negative 10. So it's, I think it'll actually bounce if this happens first. So that's an issue. Um, this is the first time I've thought about actually what would happen. So I would think that depending on the bank, they might look at these transactions and they will think of what is the best way to arrange these transactions so that we can actually make it possible if these three are happening at like roughly the same time to avoid having the check bounce because that's not good, your utility bill or whatever this bill might be. So that's one thing. Another thing is like, it was mentioned that in the case of failure or interruption. So let's say, what happens if right after this point, um, database crashes or something like that happens, right? So handling that as well. So there are many reasons why we use databases, and especially for more, as far as I know, really, really important organizations will use SQL just because of the how structured it keeps the data. And also, SQL being um, many being very scalable. you can have a lot of data in them. I guess another thing could be SQL databases, like because they're built off of the SQL language, like within them, you have the ability to do many complex operations. Like let's say I wanted to, grab all students who have an average grade of an A across across all their grades. And like not just students, let's say I just want their names. So like we'll go into that tomorrow, but like that query can actually be done very easily using a SQL database. On NoSQL, we would actually have to do most of that, like grabbing that data and doing those calculations. We would have to do it on our own, as far as I know. It's not built in. Maybe it's even more complicated. Right, so we will create the database, but there are tools we can use to make that happen pretty easily. Let's say like we have another operation. Let's say we want to grab all students who, let's say some of their assignments were not graded. So maybe some of these grades are actually like, maybe some of these grades, let's say if the grade is not assigned because of some issue, it's like an X here, and then we have a reason here. Now, let's say we have some students who are graduating. So they're all, let's just assume that it's by age. So the students are all 21, the ones who are graduating. We could, we could write a query that if we want to get the students who are graduating and who have outstanding grades of X, and then we just want to see the reasons. That is another query we could do where it's like, okay, I want to get all the students whose age is 21, so they're graduating, and who have grades of X, and then I want to see the reason. And not only that, but I actually want to see like in my result, I want my result table to look like this. I want the name and I want the reason. Like, actually, no, I want the name. I want the grade ID and I want the reason. So I want these three things. But also, the thing is, we might have the same student who has many grades that are X and then the reasons given, right? So these sort of like really, these are more complicated operations, but these are the sorts of operations that we would use in daily life quite often. Someone who is, let's say, working in like the student admin and wants to do these and like get this information very easily. So SQL has a lot of this built in, and we can very easily get these sorts of things like answers to these questions and like get the data that we need. So that's actually really important. And that's another reason why SQL is often used in these scenarios. So I'd see another question here. Is the bank account NoSQL database? So as far as I know, bank accounts are often use SQL, store data about money. I can't think of an example where it's not SQL. And I think a lot of it might just be, yeah, the fact that the tables are all related already, you can build in these relations very easily. And the fact that we have access to the SQL queries to get certain information. This is a great question. Can we use NoSQL and SQL in one project? You probably could, but I think it would be pretty complicated because it would be a lot easier just to stick to one. So use one or the other. Using both of them, it would be like, okay, some of your database will be on SQL and some of it will be on NoSQL, and that trying to like do, if you have information in one and then trying to get something from another one, um, would be complicated. You'd have to do a lot of processing or a lot of code writing on your own end to do that. Let's say if everything is just in SQL, then you could very easily, it's just in one place. Or if everything is in NoSQL, it's also much easier. All right. What is the most using and recommended tool in industry right now? So in again, I'm just answering in my experience, I have only worked with in industry only with SQL. Yeah. I see another comment here. Okay, interesting. So a case where NoSQL is better than SQL. Secure save media files better, NoSQL. Okay. Can we convert SQL to NoSQL structure? We probably could, but it would be pretty complicated, I would imagine. Each table would, so each of these actually, let's actually go into NoSQL and then we can talk about what might be similar and how we might convert the two. So let's talk about NoSQL. The NoSQL is built around the idea of documents. Now, this is semi-structured. It can be unstructured, but it's a lot more flexible because we don't enforce documents to look a certain way. They can have extra fields, whereas here, you can only really have these three fields in each, let's say, let's call them in each row that is within this table. So actually, the row here is analogous to a document, and the table is analogous to a collection. They're not exactly the same, but we can think of it in that way. So let's actually talk about, okay, so let's say we have a student's collection. Okay, so we have a student's collection, and it would look like this. So let's say we actually store these as documents. And so documents, it's very similar to like a JSON, but slightly different. That's how NoSQL stores it. So let's say this is one document, ID 1, name Joe. Joe, age was 19. And notice that it is a set of key value pairs. So it's essentially just an object, a set of key value pairs. And the next one is 2, and then the name was Amy. And then the age was 21. And then let's just put the proper array braces. So it's like that. Yeah, so the mock API we used was NoSQL because it was storing, I guess it's most similar to NoSQL. We didn't have any SQL like querying that we could do, and the data storage was in the form of a JSON. Yeah, that's correct. Okay, so we have that, and then let's just say, okay, I'll just do one more table. I'll just do the grades table. And then maybe like, sorry, not table, the grades collection. Yeah. And then remember the grades, we had ID 1, and then you could call it student ID, or you could just call it student. And then you would put like, who was this, Amy? Okay, so this is 2, and then the grade was an A. So that's sort of what it would look like. And then the idea is that, let's put one more object, one more document. Student is 2. Let's just put grade as A as well. So Amy got all A's. And yeah, so this is references us to this. Now it's not quite as clear, like in the sense of when we create the collection, we do not say that, well, actually, we do, right? My mistake. So we can actually, it's similar in the sense that when we create our grades, like we don't create the table itself, but we create this. Like we create the schema for what this data looks like. And we'll see this in the code too. ID student grade. And so we would have to say this ID is actually, well, we're going to store it as a string. But in this grade, let's say, is a string too. But this student, we call it something called object ID. Because, well, this is also an object ID, actually, so let me fix that. We convert it into a string later. This student here, this object ID, we reference the student collection when we create it. Or, better, let me actually double check an example. I just want to confirm. Yeah, so we reference this student here. And so it knows that, okay, the value stored here is actually going to be something like this. It's going to be the student. So it's similar to foreign keys, but it's not exactly the same. Also, let me correct this. My bad. There's no ID. Like when there is an ID, obviously, because we can see one here. But when we create it in our code, we don't need to put an ID. The ID is handled by the database, okay? But this part we do need to have in our code. We do need to say that the student is an object ID, which is actually these. Like these are not strings. NoSQL databases have a very special way of storing IDs. Object ID is like you can think of it as it's like I think it's like a 12 sequence or 12 letter string, like 1, 2, AC, so on, so on. It's like its own sort of data type here. So that's actually what an ID looks like. And so that is what goes here inside the student, right? That's what this is. And that's how we link these two. Just like how in the SQL database, it uses foreign keys. This is how we use in, let's say, a NoSQL database, how we link these together. Yeah, so it's a good question. We have to consider the primary and foreign key relationship ourselves. Yes, so that is something that you'll have to think about. What, given the project, let's say something that you're working on, what sort of data might we use, and then how might we actually reflect this in our code? How might we think about this? Now we will give like all the hints. I think the next assignment that is this Friday will be making an SQL database and like doing some fun queries with SQL. And like although we will provide all the information that's necessary to build this database and like what sort of data we're going to be working with. And we will, I mean, throughout the week, we'll constantly see more examples of SQL and NoSQL databases, but especially SQL databases and how we work with those. And actually, I think tomorrow we found a little interactive website that we can go through. Which SQL will be worked? Sorry, I don't understand that question. No. So MongoDB is, okay, so there's two things. So we're going to use, I believe it's called PG admin. And this is like through the render server. And that is for SQL. And then we will use MongoDB for NoSQL. So all of this that I've been talking about for NoSQL, I'm just in the context of MongoDB, I'm explaining how MongoDB handles it. There might be like slightly different setup for different NoSQL applications or tools for NoSQL databases, but as far as we're concerned, we're using MongoDB. Okay. Right. So for the assignment, it will be on render or PG or SQL. But that will go into like over the next few days in this week. We'll cover all the tools that are necessary, and then the assignment will have, very clear instructions on how to set things up step by step. Yeah. Yep, render is free. All right, so that is more or less all the topics I wanted to cover, which was just sort of a review of what we saw this morning, and also just looking at some examples that sort of highlight the differences between these two databases. It's funny because I like NoSQL for the ease of use, but now that I'm seeing, like this sort of stuff, if you have an organization that you're running an organization and you need a robust database where you can very easily run queries to check things and to do things and to let's even update things. I don't think anything can beat SQL. Like, if you are, let's say, like a school and you want to find out, okay, I want to see like all the names and the IDs, even like the student IDs of all graduating students. So age, let's say 21. And I want to get, link to that. I want to see all their, the grade IDs where they like for the grades that are X, so unmarked. And then I want also the reasons for each scenario. Like that is something that I think SQL can really shine in getting that. Doing that with NoSQL would be extremely difficult. And actually here, I'll just extend this. In this case, these two would be the primary key. The grade ID and the name, right? Because it can't just be the grade ID because, well, actually, each grade is unique. So it could be the grade ID. Yeah, that's true. It could be the grade ID. So yeah, we could have a composite primary key. We could have grade ID and the student ID. It could just be the grade ID because every assignment has a unique ID that and like the same one student cannot have the same assignment like ID. Although maybe if you allow students to redo assignments, then it could be the same assignment ID. So that might actually change things. Right. So GID is unique because let's say in this scenario, every assignment is submitted once. Actually, this is a really good question. I think I actually made a mistake. So why is the grade ID unique? Right. So now I'm thinking maybe it's not unique actually, because the grade ID is, if it's linked to a grade that we assign to the student for something, and maybe grade ID is not even the best way to think of it, because a grade always has to be linked to an assignment, right? So in that case, assignment or problem set or whatever that might be has an ID associated with it. But two students can have the same grade ID, because um, they can both complete the same assignment and have different grades. So you're right, actually. In that case, this table, to make every entry unique, we would probably have a composite key. The primary key would be the grade, like the ID of the grade, which is really just the assignment or the problem set, and the student ID. It would be both of these. So that's a good point. Okay. So I mean, I came up with this pretty quickly. So there might be some issues with how we might be making these unique. Yeah, but we'll see more examples tomorrow of databases, and these are like where we can run queries and we can do things. And I think then we'll really see the benefits of SQL and why many organizations use SQL for their databases as opposed to NoSQL. Okay, so does anyone have any other questions on anything that we covered here? Why we use databases, and then also SQL versus NoSQL. Okay, so I see one more question. Why don't we let the course ID be the primary key? Where is the course? There's no course table here. And every course had multiple assignments. If we have, okay, so if we had, let's cover that example. So let's say we did have a course table. Instead of a grades table, yeah, there are many ways to like organize this. I just came up with this one, but it's actually not that great. I think better than a grades table, have an assignment table. But you're right, like it's probably even better to have, like, you could probably have a course table. So you have course ID, and then your assignment table has the ID of each assignment, but then it also probably has a course ID. And then the primary key is both of these together, because you cannot have the same like assignment be in the same course twice, right? So this would probably be a better way to arrange it. Because, so each assignments might be unique, but the primary key also has course ID. And maybe even, if we want to, and then, in that case, maybe the grades, we have an ID. The grades have an ID, like the ID of the grade itself. It has an assignment ID, which assignment is it linked to, and then maybe even a student ID. And then all three of these are the primary key for the grade. So Is it possible two primary key that we have for one table? So no, we only want one primary key, but we can make it composite. We can have multiple things in that key. And I see another one, but every assignment will be in one course. So not necessarily. Even for this, you can have multiple assignments in the same course, right? Because we can have ID1 course ID1. We can have the ID2 course ID1, ID3 course ID1. These are three assignments that are all linked to the same course ID. So they're all in the same course. I think so. This example, it'll become more clear tomorrow. Tomorrow we'll be going through some SQL practice, and then inside of that, we'll be seeing like there is actually maybe I can here SQL practice. So we'll be going over this tomorrow, and maybe they don't have. Oh yikes! They don't actually have a student example. Well, that's okay, but we'll be seeing the same thing. Like this is actually a database, and maybe I can show you guys. Um, Check this out. So this is actually how it might be organized here. And notice this. So this is an SQL database for a hospital. And notice here, patient ID. So this is unique for every patient. But this is cool. So we have patient, and then we have province ID here, Ontario. And if we go to province names, notice that this ID is it's a char. It's almost like a string, but it's two characters, so ON. And then we have a name linked. So here we have ON Ontario. So the patient, yes, they have their primary key, which is the ID. But we also have here, this is a foreign key, province ID, that connects it to the province names table, province ID, Ontario, and we see Ontario here, or ON Ontario. We even have, maybe this is a bit better, admissions. We have an admissions table to keep track of like which patients came in today, right? And notice here that we have the same, so patient one came in twice. They came in on November 6th, and then they also came in on September 20th. And then they were discharged at these different dates. And then the diagnosis, and then even the attending doctor's ID. So the ID of the doctor that saw them. So we might want to think, okay, what should the primary key be of this table so that every entry is actually unique, right? Probably not the patient ID and the attending doctor ID, because we could probably have the same patient attend at different times throughout the year with the same doctor. So maybe the primary key is going to be the patient ID, the attending doctor ID, and the admission date. Because or who knows, maybe they are admitted twice. So we might want like more fields in that primary key. One more thing that's interesting. So this attending doctor ID 21, 24, right? Like this is linked to the doctor's table here, where this is also numbers. So we can see here. So who was the doctor that helped? So patient one, we can find who this patient was. So that was Donald Waterfield and from Ontario. And Donald Waterfield was with the doctor with an ID of 21 and 24. And so if we go to doctors here, the ID of 21, so Lisa Cuddy, and then 24, Jenny Pulaski. And let's see, does it match up to, so let's see, 24, a neurologist. And so if we go to admissions, ineffective breathing pattern, I don't know if that's, well, it could be, I'm not sure. But Yeah, this is just an example, and we'll work through this tomorrow. We'll see, like, if this is your database that you're working on, right? If obviously your database won't be nearly as complicated as this, but if it is, or even if it's not complicated, you know, answering the question of like, okay, I want to find all patients who worked with this doctor who were discharged during this year, like these sorts of things that probably will need to be found, right? Those are things you can do if you use an SQL database. You can write a query that can find that. And that's something we'll cover tomorrow. So I just opened this because I thought this was pretty cool. And I thought I could show you guys like how the tables are related in this case, and like, a bit of a better example than the student one that I came up with. Does anyone have any questions about this? Of course, yeah, no worries. And maybe I'll even send this in the chat. So, and for people who are seeing the recording, it is www.sql-practice.com. You can like just you can click. There's also Northwind, and you can just like take a look at like what these are. You don't need to worry too much about running these queries and like what these mean. That's something we'll cover tomorrow. But just taking a look at how these are all connected to one another is also often pretty good. Customer ID, ALF key, uh, orders. Order is also has customer ID. So let's see if we want to find which orders did this guy Alfke, Alfred's Uterkist? Oh no, that's the company. So Maria Anders. So which orders did she make that were over like the unit price, maybe like over $20 or something like that? So these are all things that we can do, and they're pretty fun to do. All right, so that's about everything for today for this like review lecture. And yeah, guess I will, that's about it. And we're going to use the rest of the class just, open for like questions.